So in this video we're going to learn more about definite integrals. We're going to learn some of the basic algebra rules that you can use with them. And so just as a reminder, so far we know that to find a definite integral, to find things where we have it written like this with the limits in place. Now we're not doing like an antiderivative with a plus c like we thought of before. So far what we know is we're going to be taking the area under the curve of f of x from a to b, and we will be using geometry to do that. So let's learn a little bit more about some of the algebra that can go into that. These are basically the rules that we're going to use in this section, and so I just want to quickly run through them. The first one says if you were to think of the area under the curve from a to b of this function, if you were to flip the limits, so now b is going to be what we think of first going to a, the only thing you'd have to do is take the opposite of your original answer. There's that negative symbol out front. So if you reverse the order, you get the opposite answer. Second rule, if the limits are exactly the same, so from that x value to itself, you're not really covering any ground, so there's no area to find, so that answer will always be 0. Third rule, if you have a constant or a number inside that definite integral and it's being multiplied by the function, you can just go ahead and factor that out to the front and then just find the area under the curve first and then multiply by that constant. Rule number 4, you may add or subtract functions within this integral, and if that ever happens, feel free just to split up this bigger integral into two separate small integrals. Just find the integral of the first function and the second function separately, and then add or subtract them together depending on what the question asks you to do. And then finally, the fifth rule here, let's say you're finding the area under the curve from a to b and then from b to c. So notice that the ending point here is the starting point for that one. You can just go ahead and combine this idea into one single integral from a to c. So if you are looking closely at the starting and ending points, you could say, of your integral, sometimes you can come up with a shortcut. And sometimes it's helpful to think from here and get this. Sometimes you're going to have to go from here and get this, the two separate smaller pieces. So let's look at a few examples using these rules. So we know that from 2 to 6, the area under the curve of function f is 10, and also from 2 to 6, the area under the curve of function g is -2. We're going to answer these following questions here. So the first one, what's the overall area if I were to add function f and function g together? So for this one, we just want to split that up into two smaller pieces. We want to first look at what is the area of f of x going to be, and we will then add the area for g of x. And so that would be 10 plus a -2. Our answer should be 8. So I'm writing a lot of work out here just so you can see how the rules work. You feel free just to kind of think through it this way, and most of the time that work is not that necessary. Okay, our next example, we'll just go a little bit lower here. Now it's using subtraction, so again we would start out from 2 to 6. Now notice that, sorry, it's a 6 right there. Function g came first, so we want to figure out that first. Then we're going to subtract the integral of function f. And so in this case, we'd have a -2 minus a 10, and here our answer would be -12. Third example, now we're using this multiple rule. So what we can do, if it's 3 times f of x, and we're finding the definite integral, feel free to factor that 3 out to the front. So we're going to look at it from 2 to 6. It's just f of x dx. So that would give us 3 times, and the overall integral of function f for these limits is 10. So 3 times 10 gets me 30. And then for letter D, now we're doing this we're adding two things together, so we need to think through this a little bit more carefully, perhaps. Probably the best way to think of this is, we'll go 2 to 6 of f of x, d of x. And remember, 2 is also a function, so I can split it up like this. I know that the first one was 10. Now we need to think about what this next one will be. This is the function y equals 2. That's just a horizontal line. It will always have a height of 2. We're looking at a width from 2 to 6 of 4. So if we were to draw a picture of this, feel free to draw that picture if you want to. A height of 2 and a width of 4, that's just going to be a rectangle in the end. So I'm going to be looking at an overall area of 8 that I'm adding to it. And so my answer here should be 18, I believe. Now we're given a little bit different info for the next example. We're dealing with the same function. Now they have different limits. One is from 0 to 5, and then the other integral is from 5 to 7. And we know that the areas are 10 and 3. So if I want to know what's going on from 0 to 7, so we'll do part A right here. I could say that if I think of the limits, I can just take from 0 to 5 of f of x dx, and I can add from 5 to 7 of f of x. Again, this part you probably don't need to write down if you can see what's going on. But the first integral is 10. The second integral was 3, so overall my answer would be 13. Part B, again, just kind of move down right here. Now we're looking what's going to happen from 5 to 0 of f of x. Well, according to our rules, I could flip the limits and just find this as long as I made it the opposite of what it was. So hopefully you caught that. From 5 to 0, I just flipped from 0 to 5 now, but I need to put a negative symbol out front. And so in this case then, if the original was 10, this answer would be negative 10. We're working backwards there, you could say. Example C. So we're looking at the area under the curve of f of x from 5 to 5. Well, there is no area there. There's nothing that we're covering. We're not moving from one x value to another. We're staying stationary, so right away this answer would have to be 0. It can be that simple. And looks like part D, we're using that kind of common multiple rule again, so I can feel free to take the 3 out to the front, keep the limits the same here, and now I'm just dealing with function f inside. The overall derivative from 0 to 5, I'm sorry, not derivative, the integral from 0 to 5 was 10, so I need to go 3 times 10, which should give me 30. So, just a little practice with some of the basic rules, and hopefully you're familiar with them, and you can feel confident when you come back to class tomorrow and try a few of these.